February 20, 1943, north of the Kasserine Pass in Tunisia, dawn broke over a battlefield that would later defy the capacity of any official report to convey what German tank crews actually witnessed. That morning, something unfolded that seemed to violate the accepted boundaries of armored warfare as defined by Wehrmacht doctrine. Out of the blowing grit and drifting smoke, American M4 Sherman tanks performed movements no German commander believed possible without the use of visible signals. Across scarred ground where broken ridges and gullies blocked all lines of sight, 5 Sherman tanks advanced as though guided by a single mind. They moved toward German positions from different directions, navigating terrain that should have prevented any coordination. No signal flags cut the air. No flares arced skyward. No dispatch riders darted between armored columns. Yet each vehicle shifted, slowed, or surged with uncanny precision. Every tank shielded the blind angles of another as if the crews shared a common vision of the battlefield. Soldiers watching from Panzer IVs equipped with FUG-5 radios found themselves unable to comprehend how the Americans operated with such fluid unity. Inside those German tanks, commanders strained to hear their own superiors through static-clogged amplitude modulation radios. The FUG-5 sets, which had represented cutting-edge technology a decade earlier, transmitted with a nominal power of 10 watts, sufficient under laboratory conditions, but almost useless once engines rumbled and tracks churned across rough ground. In motion, the German radios often managed only a few hundred meters of reliable communication. Many Panzer crews possessed radio receivers only, incapable of transmitting updates or warnings. Even full transceiver tanks struggled to maintain contact. The Americans, however, were fighting with a technology the Germans did not yet realize existed. Every U.S. medium tank carried a frequency modulation radio, crystal-controlled and capable of transmitting 25 watts, more than double the German output. Their voices cut cleanly through engine roar, electrical interference, and the chaos of battle. What the Germans saw that morning was not supernatural coordination. It was the power of equipment that allowed every American tank crew to share information in real time, forming an unseen web of communication that the Wehrmacht had no means to match. Nearly 8,000 miles from the assembly lines of Detroit, the advantage that would reshape armored warfare was revealing itself, not through thicker armor plate or heavier guns, but through invisible electromagnetic connections linking U.S. tanks into a cohesive fighting entity. The roots of this transformation reached back to July 22, 1941, when the U.S. Army formally standardized the SCR-508, SCR-528, and SCR-538 radio sets for medium tank use. At the very moment German armored columns were driving deep into Soviet territory using outdated AM communication systems, American engineers at the Galvin Manufacturing Company, later Motorola, were finalizing FM radio designs that rendered German equipment obsolete. Among the leading minds behind this shift was Daniel E. Noble, the engineer who envisioned applying FM technology to armored vehicles. Working alongside him was Henryk Magnuski, the principal RF engineer responsible for solving the technical obstacles of fitting sensitive electronics into the shock-ridden interior of a tank. Their creation, weighing 181 pounds, effectively turned each Sherman into a node connected to a larger battlefield communication grid, the first of its kind in warfare. The BC-604 transmitter output 25 watts, 2.5 times the FUG-5. Operating between 20.0 and 27.9 MHz, it offered 10 preset channels with crystal-locked stability. Its companion components, the dual BC-603 receivers, allowed tank commanders to monitor multiple frequencies at once, a capability unknown in German armor. The revolutionary leap, however, came from Edwin Armstrong's frequency modulation technology, licensed to the U.S. military. FM suppressed interference that crippled AM radios. Where German radios absorbed every electrical pulse as static, American sets delivered clarity even under artillery fire. When Operation Torch began on November 8, 1942, and U.S. armored units landed near Safi and Fadala, these radios entered combat for the first time. The Afrika Korps, among the Wehrmacht's most seasoned armored formations, now faced opponents with communication capacities unlike anything they had encountered. German platoons relied on a brittle structure. In a 5-tank platoon, only 1 or 2 vehicles carried a full FUG-5 transceiver. The rest could only listen via FUG-2 receivers. If the command tank fell, easily recognized by its antennas, platoon cohesion collapsed. By contrast, every Sherman could assume command instantly. The first dramatic example of this appeared at the Battle of Kasserine Pass, February 14 to 24, 1943. Although tactically a German victory, Wehrmacht observers left shaken. U.S. units maintained communication across 50 miles of rugged terrain. Crews who had never met coordinated movements through crystal-clear FM transmissions. German signals units monitored American traffic and expressed astonishment at the clarity and range. They noted that every American tank seemed to possess transmitting capability, unlike German formations where only select vehicles carried full radios. Meanwhile, FUG-5 radios, operating on AM between 27.0 and 33.3 MHz, were crippled by interference. They achieved only 2 to 3 kilometers range stationary and mere hundreds of meters while moving, drowned under the roar of their own engines and electrical noise. September 1943 brought American armored forces into Italy, where steep ridges and fractured valleys should have shattered communication entirely. Yet the mountainous terrain only underscored the strength of frequency modulation. The SCR-508 radios performed with remarkable clarity in narrow defile where amplitude modulation systems collapsed. As U.S. tanks advanced toward Cassino, crews coordinated through twisting canyons where visual signaling was impossible and German radios dissolved into static. American platoons separated by entire ridgelines moved with synchronized precision that German doctrine deemed unimaginable without sight. Reports from the 1st Armored Division documented these feats with clinical detail. They described routine communication across distances that German tank crews could not approach. The FM signals absorbed and defeated multipath distortion, the echoing and reflection common in mountains, far better than AM. American tanks that should have been blind instead maneuvered as though fighting across an open plain. On June 6, 1944, as Sherman tanks surged ashore at Normandy, their SCR-508 radios maintained contact not only with other tanks but with naval fire support ships offshore. Such coordination exceeded anything German equipment could match. But the hedgerow fighting revealed a deadly vulnerability in the American communications architecture: incompatibility between tank radios and infantry radios. Infantrymen carried SCR-300 sets operating on 40.0 to 48.0 MHz, outside the Sherman's 20.0 to 27.9 MHz range. The inability of riflemen to warn tanks of Panzerfaust teams hidden in the hedgerows led to heavy losses. American ingenuity moved fast. Within weeks, tank crews improvised a solution that forever changed tank-infantry cooperation. 8 field telephones were mounted in ammunition boxes welded to tank exteriors and wired directly into internal intercoms. By the time Operation Cobra began in late July, infantrymen could lift the handset, strike the box once, and speak to the crew inside. This simple innovation carried enormous consequences. From July 25 to 30 during Operation Cobra, the U.S. 2nd Armored Division under Major General Edward H. Brooks displayed what full radio supremacy meant. Coordinating more than 200 Shermans across fluid battlefield lines, the division reacted with a speed the Panzer Lehr Division could not counter. American tanks repositioned instantly according to reports from miles away. Artillery summoned through radio arrived within minutes of target detection. The contrast was devastating. Panzer Lehr, once Germany's premier armored formation, had by mid-1944 become crippled by communication shortages. With many tanks lacking radios, crews relied on hand signals or visual cues, nearly useless in hedgerows where sight lines collapsed at 10 yards. Even tanks equipped with functioning radios faced interference, drift, and short range. Counterattacks arrived uncoordinated and were overrun by American forces directed through reliable FM networks. The irony was striking. Germany, the pioneer of radio-driven armored warfare, now lagged behind. Heinz Guderian, architect of Blitzkrieg, had emphasized radios as the heart of armored maneuver since the 1920s. His 1937 work Achtung, Panzer identified communication as the decisive element of tank warfare. Yet by 1943, German production could not furnish the radios his doctrine required. Production reports detailed the crisis. In 1943, Germany built roughly 5,700 medium tanks, but fewer than 2,000 complete FUG transceivers. Many went to command vehicles and assault guns. Regular line tanks frequently entered combat incapable of transmitting. Tank platoons thus depended on one speaking tank while others fought mute. The Soviet situation was even more dire. E-34 tanks, though produced in unprecedented numbers, often lacked radios entirely. Red Army doctrine relied heavily on flags and prearranged plans, leading to catastrophic losses in 1941–42. Lend-Lease later supplied some Soviet units with SCR-508 sets, but by 1945, only about a quarter of Soviet tanks carried radios. Against this backdrop, the American accomplishment stood unmatched. While the Soviets struggled to radio-equip even a fraction of their forces, the United States achieved 100% deployment of sophisticated FM systems. Motorola's Chicago facility became a symbol of American industrial might. Before the war, Galvin Manufacturing built car radios. Transitioning to military production required total retooling and solutions to unprecedented engineering challenges. Each SCR-508 contained 2,748 components able to withstand shock, vibration, heat, cold, dust, and moisture. The BC-604 transmitter alone housed 474 capacitors and 385 resistors. Crystal oscillators had to endure extreme battlefield conditions without drifting off frequency. Production statistics revealed the scale of U.S. manufacturing power. 1,942, 3,800 SCR-508 family radios. In 1943, 11,400 units. In 1944, 24,000 units. Total wartime production, over 50,000. Because of this output, all 49,324 Sherman tanks produced during the war received modern radio equipment, an accomplishment unmatched by any other nation. The advantages extended further. Crystal-controlled tuning ensured that preset channels remained stable despite combat shocks. German FUG-5 radios, using dial-tuned capacitors, drifted off frequency constantly. The SCR-508's dual BC-603 receivers allowed commanders to monitor both platoon and company networks simultaneously, improving situational awareness. The BC-606 intercom enabled crew communication, while throat microphones and noise-canceling headsets ensured clarity despite engine roar. German tanks often lacked intercoms entirely, forcing crews to shout or tap shoulders. Power flexibility provided yet another edge. The SCR-508 automatically adapted to 12 or 24-volt systems, drawing from a dynamo motor that filtered interference. German radios connected directly to vehicle electrical systems, amplifying spark noise into static. These communication strengths reshaped American armored doctrine. The Combat Command System, flexible task forces assembled for specific missions, relied on dependable radio connectivity. U.S. commanders mixed units freely, confident that universal radios assured cohesion. Throughout the war, German intelligence repeatedly failed to perceive the underlying cause of American armored coordination. Reports consistently acknowledged that U.S. tank units demonstrated exceptional discipline and communication, but analysts attributed this solely to training and procedure rather than superior technology. A captured German intelligence document from September 1944 stated, "American tank formations show excellent radio discipline and coordination. This appears to result from extensive training and rigid communication procedures." Nowhere did the report identify the actual reason, the unmatched capability of American FM equipment. This misinterpretation had grave consequences. German doctrine continued to emphasize the destruction of supposed command tanks, believing that only a small number of American tanks could transmit. But the U.S. system was fundamentally different. Every Sherman mounted a full transceiver. When a commander's tank fell, leadership simply passed to another vehicle without any loss of communication. German ambushes built around outdated assumptions failed repeatedly. German commanders also assumed that American tank units, once dispersed, would lose cohesion. This belief proved disastrously inaccurate. While German AM radios produced only static beyond short distances, American FM signals preserved full clarity. U.S. armored platoons retained contact even across broken terrain, coordinating movements with speed the Germans could not match. By March 1945, as American forces approached the Rhine, the scale of U.S. communication superiority became unmistakable. The dramatic capture of the Ludendorff Bridge at Remagen revealed how swiftly American units could react. When the U.S. 9th Armored Division discovered the bridge intact, immediate radio reports shot up the chain of command to 1st Army headquarters. Within an hour, large formations were repositioning to exploit the opportunity. German forces, dependent on telephone lines already shredded by Allied aircraft, had no comparable means to respond. At Remagen, Sherman tank platoons drawn from different battalions maneuvered around the bridgehead with perfect unity, all coordinated through radio networks. German counterattacks arrived in fragmented waves, each isolated and destroyed because communication failures prevented coherent action. The same pattern repeated during the encirclement of the Ruhr Pocket in April 1945. American armored columns from the 1st and 9th Armies executed a massive double envelopment covering hundreds of square miles. The entire operation was coordinated through radio communication. Inside the pocket, roughly 325,000 German troops quickly found themselves cut off as American fighter bombers systematically destroyed German command posts and communication lines. German units, deprived of functioning radio networks, lost all ability to coordinate. Field Marshal Walter Model's final messages before communication collapse reflected the growing desperation: no contact with adjacent units, no communication with higher headquarters, units fighting independently, coordination impossible. The psychological effect on tank crews was stark. American crews never fought alone. Even when physically isolated, their radios tied them into a larger fighting organism. German tankers, by comparison, often fought in silence and uncertainty. Otto Carius, one of Germany's most successful tank commanders, described in Tigers in the Mud the constant challenge of fighting without reliable communication. Though he rarely discussed specific radio shortcomings, his accounts revealed the heavy burden of isolation. Strategically, communication superiority reshaped the pace of the Allied advance. The U.S. Third Army's rapid drive across France depended on radio networks that maintained cohesion across vast distances. German commanders consistently misjudged how quickly American forces could move, believing dispersed units would lose coordination, a belief invalidated by universal FM communication. Heinz Guderian, reinstated as Inspector General of Armored Troops, recognized the severity of Germany's communication crisis. But by late 1944, German industry lacked the ability to manufacture the radios required to correct the deficiency. Years of bombardment, shortages of materials, and dispersed production lines rendered large-scale improvements impossible. After Germany's surrender, American technical intelligence teams examined captured equipment. Their findings confirmed what soldiers had long witnessed. German tank radios were technologically inferior, insufficient in number, and vulnerable to interference. U.S. Army Technical Intelligence Report No. 176 concluded that German sets lagged 5 years behind American equipment. Soviet engineers, given access to both seized German radios and American equipment provided through Lend-Lease, reached the same conclusion. For their post-war armored forces, they favored design principles modeled more closely on American FM architecture than on German AM systems. Production and performance statistics underscored the disparity. American radio production, 50,000 plus SCR-508/528/538 radios. A German FUG-5 production, 6,000 units. American transmitter output, 25 watts versus German 10 watts. Frequency stability, plus or minus 0.01%, US, versus plus or minus 1%, Germany. A range, mobile 7 miles, US, versus 0.5 to 1 mile, Germany. Fire mission response, 3 to 5 minutes, US, versus 15 to 30 minutes, Germany. Communication-equipped tanks, 100%, US, versus 20%, Germany. Modern armored doctrine owes much to this disparity. Post-war main battle tanks emphasized communication suites directly descended from the SCR-508 architecture. Germany's newly formed Bundeswehr adopted communication-centric doctrine, noting the defeat of superior German armored vehicles by inferior American tanks equipped with superior radios proves that information dominance outweighs platform superiority. Later conflicts validated the lesson. During the Gulf War in 1991, coalition forces with superior communication destroyed Iraqi units operating advanced Soviet tanks lacking equivalent networking. In 2003, American forces again demonstrated that network-centric warfare overwhelms platform-centric systems. The electromagnetic superiority delivered by every SCR-508 equipped Sherman fundamentally reshaped armored warfare. The radio network turned each tank into more than an independent fighting vehicle. It transformed every crew into an active node of a greater battlefield system. German forces encountered this new reality repeatedly across North Africa, Italy, France, and Germany, often failing to understand why American tanks operated with a unity that defied traditional doctrine. In environments where visibility collapsed, mountain passes, deep forests, or the confined streets of towns, American tanks maintained cohesion. U.S. platoons cut off by terrain still executed synchronized maneuvers that German observers believed impossible without visual signaling. Whether separated by ravines, ridgelines, or dense woodland, American units communicated as though fighting in open ground. The Germans could not replicate this, because their own AM radios simply did not function under such conditions. The gulf between the connected American tank and the isolated German tank became a defining feature of late-war battles. American crews fought with shared awareness, what modern militaries call situational understanding. German crews, even in Panthers and Tigers, often operated with only partial battlefield knowledge, unable to warn or support other units when needed. This persistent gap stemmed from a deeper systemic failure. German command never truly grasped the technological revolution FM radios represented. Analysts misread American adaptability, assuming strict pre-planning rather than instant coordination. The Wehrmacht's own limitations shaped their beliefs. Since German units lacked such equipment, they simply assumed no army possessed it. Even when German units captured American radios, engineers dismissed FM as overly complex, never recognizing its ability to erase battlefield noise. As the war progressed into 1945, German communication networks collapsed under Allied pressure. Telephone lines were destroyed by artillery and aerial attacks. Mobile radios, already scarce, suffered attrition in battles where they could not be replaced. Many German units entered combat with no functioning radio contact with their neighbors or higher headquarters. The consequences were devastating. During fighting along the Rhine, American maneuverability utterly outpaced German reaction times. Sherman's coordinated movements instantly. German formations, deprived of information, reacted slowly or not at all. The Remagen episode was proof. American units adjusted their entire operational posture within an hour. German responses remained fragmented for days. As Allied forces advanced deeper into Germany, this communication disparity accelerated their momentum. American armored divisions executed rapid thrusts that bypassed German formations, while other units sealed off pockets. These maneuvers depended entirely on dependable radio links that allowed U.S. forces to shift faster than German units could understand the evolving battlefield. German attempts to counter these advances repeatedly failed. Fighter bombers guided by forward air controllers equipped with FM radios targeted German command posts, radio stations, and relay points. Once communications collapsed, German resistance became scattered and uncoordinated. Units that might have mounted effective joint action instead fought as isolated groups. Tank crews felt this contrast profoundly. American crews were never psychologically isolated. Their radios tied them into a broader fighting organism. They knew where friendly forces operated, where threats emerged, and where support was available. German crews often entered battle uncertain of adjacent units' positions or intentions. The psychological impact was immense. American crews described battles as controlled and predictable compared to German accounts of confusion and disconnection. What the Germans interpreted as American discipline or luck was, in truth, the result of uninterrupted communication. By the last months of the war, the strategic implications had become undeniable. American advances that astonished German commanders, entire armored divisions moving rapidly across France and Germany, were made possible by radio coordination. German assumptions about the limits of coordination collapsed in the face of an enemy whose tanks communicated constantly and reliably. Heinz Guderian recognized the crisis and urged greater radio production, but by the time these warnings were issued, German industry lacked the capacity to respond. Bombing raids, material shortages, and dispersed production made large-scale improvements unattainable. After the surrender, American intelligence teams evaluated captured German communications equipment. Their assessments reaffirmed what U.S. crews had known all along. German radios were outdated, insufficient in distribution, and easily disrupted. Soviet evaluators reached similar conclusions and adopted post-war tank communication designs more in line with American FM systems than with German AM architecture. The SCR-508 represented not just an improvement, but a leap forward. It enabled coordination across terrain that otherwise isolated units, allowed rapid tactical decisions, and linked tanks into a cohesive system. In engagements from Tunisia to Germany, this invisible network shaped outcomes more decisively than armor or firepower. The electromagnetic spectrum had become a battlefield of its own, and in this arena, American forces achieved total superiority. The revolution introduced by the SCR-508 did more than enhance the Sherman. It redefined what a tank represented on the battlefield. No longer was an armored vehicle simply a mobile gun platform. It became a connected element in a vast communication web. Each Sherman contributed to a collective intelligence that the Germans never fully understood. This seamless network allowed American armored units to maneuver with a unity unmatched by any other force of the era. To many American crews, this advantage felt ordinary. From training onward, dependable radio communication was woven into the fabric of their operations. Speaking across platoons, coordinating with infantry, or calling for artillery felt natural. Only after confronting German armor did American tankers appreciate just how decisive their communication advantage was. The Germans, often equipped with vehicles that exceeded the Sherman in armor or armament, still lost engagements because they fought in isolation. This pattern repeated across every major theater. At Kasserine Pass, in Italy's rugged mountains, through Normandy's tangled hedgerows, and across France's plains, German tank crews witnessed an American force that operated as a unified organism. They saw Shermans shift formation with precision even when separated by hills or thick forest. They saw coordinated American counterattacks form almost instantly. What they interpreted as advanced planning was often on-the-spot improvisation enabled by radio clarity. German armored units, by contrast, frequently entered battle with only a fraction of their tanks equipped with full transceivers. Subordinate vehicles could not report enemy movement or request support. When commanders were killed, platoons lost coordination instantly. Even German tanks superior in raw engineering, such as Panthers and Tigers, were handicapped by communication scarcity. This gap became one of the war's decisive miscalculations. The Wehrmacht poured immense resources into tank design, metallurgy, and ballistics. But the belief that superior armor and firepower would compensate for communication deficiencies proved fatally flawed. German commanders often marveled at what they perceived as American omniscience, the uncanny way Shermans seemed aware of threats before they appeared. They assumed American units had far more command tanks than they did. In reality, every Sherman was a command tank. By 1945, German crews privately admitted the impossibility of defeating a force so interconnected. Many described fighting blind, unable to signal for help or even notify nearby units of enemy positions. Meanwhile, American tanks, fully integrated with artillery, engineers, infantry, and air support, responded to shifting battlefield conditions at speeds German units simply could not match. This networked approach to armored warfare was revolutionary. Even though the SCR-508 was an analog device, the principles it enabled, shared awareness, cooperative engagement, rapid information flow, were the foundation of what future militaries would call network-centric warfare. The world's first battlefield network was not digital, it was built on FM radio. Historians often struggle to explain how Sherman units defeated technically superior German tanks. They cite reliability, numbers, logistics, and training, all legitimate strengths. But underlying these factors was the most decisive element: communication. The SCR-508 allowed American tank units to fight not as scattered vehicles but as synchronized extensions of the same command structure. This truth is captured in Field Marshal Wilhelm Keitel's often-quoted remark during Germany's surrender: "We knew how to build better tanks, but you knew how to make them work together." Whether the quote is literal or apocryphal, it reflects a widespread understanding among German officers. German armor, no matter how advanced individually, operated as isolated combatants. American armor operated as a system. A Panther fighting alone could be defeated by multiple Shermans acting cooperatively. A Tiger without coordination could be flanked, isolated, or overwhelmed by forces that communicated instantly and continuously. The Americans learned a simple truth: a tank's greatest weapon was not its gun, but its radio. Shermans used this strength to outmaneuver, outcoordinate, and overwhelm even technologically superior adversaries. By 1945, this transformation was complete. From Tunisia to the German heartland, American forces revealed that information, transmitted through the invisible electromagnetic spectrum, had become the most powerful resource in warfare. The Sherman's radio network was not simply an upgrade, it was a revolution. It changed the battlefield forever. Coordination triumphed over isolation. Information flow defeated mechanical superiority. And the connected overcame the disconnected. In the final months of the conflict, the full scale of America's communication advantage had become undeniable. The SCR-508 transformed the M4 Sherman from a merely adequate medium tank into a vital node in a vast, interconnected battlefield system. Every Sherman crew operated not as an isolated fighting entity, but as part of a unified combat network capable of reacting faster and more coherently than any German formation. German armored forces, even when equipped with superior vehicles such as Panthers and Tigers, found themselves repeatedly outmaneuvered by Shermans that shared real-time information. A tank, regardless of its firepower, could not defeat what it could not anticipate. And American tank crews, supported by instantaneous communication, anticipated almost everything. What German observers interpreted as uncanny timing or perfect coordination was actually the product of real-time data flowing across hundreds of American vehicles simultaneously. Because German AM radios broke down under engine noise and terrain, their crews often fought blind. They received incomplete or outdated information and frequently found themselves surprised by American maneuvers that seemed impossibly synchronized. The Wehrmacht never adapted to this reality. They continued to believe that American coordination stemmed from prearranged plans or unusually high numbers of command tanks. They never grasped the devastating truth: every Sherman had a command tank's capability. When American platoons attacked from multiple directions, adjusted instantly to changing conditions, or coordinated with artillery in minutes, German commanders attributed it to elaborate planning. In truth, it was the natural result of continuous communication. This disparity expanded even further during combined arms operations. The SCR-508 allowed U.S. tank commanders to work directly with infantry, engineers, artillery observers, and even air support units. American armored thrusts often operated under the protective umbrella of coordinated firepower, all linked by dependable FM signals. German forces, unable to replicate this level of cooperation, found themselves repeatedly defeated by American units that behaved like one organism rather than scattered elements. As operations continued at Remagen, beyond the Rhine, and across central Germany, communications superiority accelerated the German collapse. The more the Wehrmacht's infrastructure crumbled, the stronger the American network became. With every German radio post destroyed and every telephone line severed, German units slipped further into isolation while American units moved with increasing cohesion. The fighting in the Ruhr pocket demonstrated this shift with brutal clarity. American columns maneuvered across vast distances with near-perfect synchronization, while German units, deprived of communication, were encircled before they realized their flanks had collapsed. It was not superior guns or armor that sealed their fate, it was the flow of information. By 1945, even Germany's own leaders recognized the truth. Field Marshal Wilhelm Keitel's famous remark, "We knew how to build better tanks, but you knew how to make them work together," whether authentic or apocryphal, captured the essence of the German failure. The Germans built incredible machines. The Americans built a network. This marked the beginning of a new era in military science. The revolution historians now call network-centric warfare did not originate with satellites or computers. It began in 1942 when the first SCR-508 equipped Sherman entered combat. From that moment, armor superiority was no longer decided by the might of a machine but by the strength of its connections. The invisible electromagnetic waves that linked Sherman crews together proved more decisive than the most advanced armor-piercing rounds Germany could produce. Coordination triumphed over isolation. Real-time communication defeated individual tank superiority. And in every major theater, from Tunisia to Italy, from Normandy to the German heartland, the connective power of the SCR-508 reshaped the outcome of armored combat. By war's end, it was clear. The true weapon of the American tank was not its 75mm gun, nor its armor, but its radio. The Germans had never understood this advantage, and by the time they realized the nature of the threat, the war had already been decided.